On behalf of 24houranswers.com, I welcome you to today's lesson. In this video, we're going to look at a definite integral, and if you've been watching part 1 through part 5 with the U-Substitution series of videos, this part 5, this example should look familiar, except now we have a definite integral. We have some bounds. This exact same indefinite integral was covered in part 4, where we used some U-substitution to evaluate this antiderivative, and we got this for our answer down here. I encourage you to watch this video here before proceeding to see how we did get this answer, and now we're going to apply, this definite integral. We're going to apply these bounds to this problem. So I just copied that answer over from the part 4 video. Again, check that out before proceeding, but I'm going to erase this plus c. And there's two ways we can evaluate definite integrals when we have U-substitution going on. This is the first technique, and though it's not my preferred technique, I'm still going to show it to you anyway because there's absolutely nothing wrong with doing this. Like all definite integrals, if you have bounds, once you find your antiderivative here, we want to take those bounds and we want to plug them in. So we're going from 0 to pi over 4 according to our problem. Now, just checking this over in Desmos real quick, we should get 3/4 or 0.75. So let's see how we get that. Let's take the pi over 4 and let's plug it into x. So therefore we have 1/4 with the cosine of pi over 4 to the 4th power at the bottom. All we did here was plug in the pi over 4. Now let's come and let's plug in 0. Same thing here, plugging in 0 for x, and don't forget to subtract these two values, and now let's evaluate this. So we have the 1/4 down here, cosine of pi over 4. Cosine of pi over 4 on the unit circle is square root of 2 over 2, this is to the 4th power. Minus, bringing it on down, 1/4. Cosine of 0 is 1, well we have 1 to the 4th. Let's evaluate a little bit further, we have 1/4. The square root of 2 to the 4th power. Well, here's how I think about that. I think about it as the square root of 2 squared, and then all of that is squared. We'll worry about the 2 to the 4th in a second. But the square root of 2 squared and all of that squared is the same thing as the square root of 2 to the 4th power, because we could multiply these exponents. Well, the square root of 2 squared is 2, and then 2 squared gives us 4. So therefore, what we have down here inside of this fraction, the square root of 2 to the 4th is going to be 4 over 2 to the 4th power, that is going to be 16. Minus, and this one here, not as bad, this is just going to be 1/4 since 1 to the 4th power is 1. Moving on here, we have 1 over 4 times a 4th. 4 over 16, if we take 4 over 16, we write that as 1/4, since 4 over 16 is 1/4. A 4th of 4 is equal to 1. Therefore, we have 1 minus 1/4, and 1 minus a 4th does give us the 3/4, or that 0.75 that we saw over in Desmos just a few minutes ago. And there you have it. This is one technique for computing a definite integral. Basically, we're taking our x bounds. I'm emphasizing this here, x bounds, since we're integrating in terms of x. But when we come back and look at technique number 2, we can actually avoid this or dodge this by messing around with u-bounds. That may sound crazy. Stay tuned for part 6, where we'll do this exact same problem, except we will look at how to get this answer in a different technique, and quite frankly, my preferred technique. And that's it for this video. I hope it helped. Be sure to check out our YouTube channel for more videos. Links to our social media are in the description below.